Atoms have a positively charged nucleus made of protons, which are positive, and neutrons, which have no charge. And these are surrounded by the electrons, which have a negative charge. When the positive charges equal the number of negative charges, the atom is neutral. If an object gains electrons, so it gains more negative charges, it becomes negatively charged. If an object loses that negative charge, then it has an overall positive charge. Electric charge is all about electrons. Here are some scientists you need to know about. Benjamin Franklin in 1752 experimented with lightning. He found evidence of there being two types of charges, positive and negative. Charles Coulomb in the 1780s formulated Coulomb's law. He defined the electrostatic force of attraction and repulsion. The SI unit of electric charge is named after him, the Coulomb. J.J. Thomson in 1890 discovered all material has light, negatively charged particles that he called electrons, and his idea was the plum pudding model, where similar to a cookie, you had the negatively charged chocolate chips surrounded by the positive charge of the cookie itself. Ernest Rutherford from 1909 to 1911 disproved that plum pudding model. He used alpha particles and gold foil, and in this experiment he proposed that atoms are made up of a positive nucleus with negative electrons, and that the total atomic charge is neutral. When alpha particles were shot through the gold foil, most of the time they would just pass on through. But at times, the alpha particles would be deflected or would bounce back. So his idea was that there was something solid in the middle of the atom, which was the nucleus that the alpha particles were bouncing off of. And then Robert Millikan in 1910 determined the charge of an electron using a very famous experiment called the oil drop experiment. Facts about electrical charge. Like charges repel and unlike charges attract. So if you rub a balloon across your hair, the charge on your hair will be positive because the electrons have moved from your hair to the balloon, and now the balloon has a negative charge. If you put two charged balloons close to each other, they're going to repel. If you place the negatively charged balloon against a wall, the balloon will stick because the negative charges in the wall will move away and the positive charges will attract the negative charges in the balloon. Charge is always going to be conserved, can't be created or destroyed, so the positive charge on your hair will equal the negative charge on the balloon. The standard unit for electrical charge is the Coulomb, and this is a picture of Millikan's oil drop experiment, where he found that the magnitude of the charge on one electron and also on one proton is 1.6 times 10 to the negative 19 Coulomb. The charges will have opposite signs. An insulator is a material that does not transfer charge easily. So insulators have tightly bound electrons. Examples are glass, wood, dry air, and most plastics. A conductor is a material that transfers charge easily. Conductors have loosely bound electrons. Most metals are conductors, water is a conductor, and the human body is a conductor. So when charges are added to one part of an insulator, the charge is going to remain on that area. whereas when charge is added to a conductor, the charge spreads quickly across the surface of the object. Air is an insulator. In certain conditions, it can also become a conductor, as in when it has a lot of moisture in it, and then it can allow charge to transfer through it. Lightning is an example. Grounding occurs when you can eliminate excess charge by touching a charged object, like the wiring in your house, to the earth. The earth is so massive that the charge dissipates very rapidly. Lightning rods were developed by Benjamin Franklin to bring excess charge safely to the ground where they quickly dissipate. In Benjamin Franklin's day, the highest points in most towns were the church steeples. Those structures were getting struck by lightning very often, and once lightning rods were installed, the excess charge could be safely delivered down to the ground, and the charge would dissipate and the structures did not catch on fire. Conduction happens when you charge a neutral object by touching it with a charged object. The picture of the dump truck hitting the wire is an example of charging by conduction. Induction happens when you charge a neutral object by first separating the charges on the object and then grounding the object using a third object. So in this diagram, the negatively charged rod is brought close to this object, which is neutral at the beginning. As the negatively charged rod is brought close to the object, the positive charges are attracted to the negative charge of the rod. The negative charges in the object move to the opposite side. Then, by grounding this side of the object, the negative charges are drained off. Once the ground is removed and the rod is removed, then my object has a positive charge. So by induction, where I never have actually touched the object now has a positive charge. We can use an electroscope to detect if an object has a charge. An electroscope has an insulator here, so like a rubber stopper. This would be metal down the center, and this would be a metal bulb attached to two metal leaves. The conductor links the outside, so this is the outside, to the leaves that are inside. So this would be a neutral electroscope, where the leaves are just hanging down. If I bring an object near the electroscope, then the electrons rearrange. The parts will have similar charges, and they're going to repel each other.